बी इज, इन दोनों के बीच में एक नॉर्मल फोर्स होगा जो दोनों साइड एक्ट कर रहा है, उसकी वैल्यू निकालनी है. यू हैव 2 minutes. Yes, Jain, right answer. No, no, wrong answer. No, Ashwath, wrong answer. Yes, Arnav, right answer. Anyone else? Shall we proceed to the solution?
Yeah, sir.
All right. The elevator is going down with an acceleration of 2 मीटर पर सेकेंड स्क्वायर. तो इसमें अपन रिलेटिव मोशन ले सकते हैं. अपन g को सब्स्टिट्यूट कर देंगे g माइनस ए से. तो हम हर जगह g की जगह हम ले लेंगे 8. All right. Now taking the mass A into consideration, it is having a force mg downwards and a normal force upwards. So, and क्योंकि अपन ने ऑलरेडी बैलेंस कर दिया है एक्सेलरेशन को, सो n इक्वल्स टू mg. n हो जाएगा, what is m of mass 8 is 0.5 into 8. That gives me answer as 4 newtons. I think someone has joined right now. I'll just wait for 1 more minute so whoever has joined recently can try this question. Anyone having any doubts? बढ़े आगे?
हाँ सर.
All right. Next question. A body of mass 1.5 kgs is thrown vertically upwards with an initial velocity of this. It reaches its highest point after 3 seconds. The air resistance acting on the body during the ascent is. क्वेश्चन आ गया सबको समझ में? किसी को क्वेश्चन समझने में प्रॉब्लम हो तो पूछ लेना. No, Jane, wrong answer. Yes, that's the right answer. Anyone else?
1 minute.
Guys, I'll give you a hint. See, first, try to equate the forces and make an equation which looks like force equals to mass into acceleration. All right. इस टाइप की कुछ इक्वेशन फॉर्म करने की कोशिश करना एंड देन यहाँ से एक्सेलरेशन जो आएगा इसको यूज करके यूज एनी इक्वेशन ऑफ मोशन दैट इज जो अपने पास होती थी एस इक्वल्स टू यू टी प्लस हाफ ए टी स्क्वायर टाइप की और वी स्क्वायर इक्वल्स टू यू स्क्वायर प्लस टू ए एस उसमें सब्स्टिट्यूट करने की कोशिश करना.
सर आप एक्सप्लेन कर दो एक क्वेश्चन.
Alright, let's proceed to the solution then. See, first, suppose this is a body and its mass is given as 1.5 kgs. It is thrown vertically upwards with this initial velocity. Alright, so we know इस पे एक फोर्स एक्ट कर रहा है mg एंड सेकेंडली एक और फोर्स एक्ट कर रहा है एयर रेजिस्टेंस का, लेट्स सपोज f एंड इसका एक्सेलरेशन ये जा तो ऊपर है लेकिन रिटार्डेशन हो रहा है, इसका एक्सेलरेशन डाउनवर्ड्स है. तो वी कैन मेक एन इक्वेशन mg plus f equals to ma, right? M दिया हुआ है 1.5 and g is 10, so 1.5 into 10 plus f equals to 1.5 into a. यहाँ से a मेरे पास में आ जाता है 15 प्लस f अपॉन 1.5. और ये f के टर्म्स में भी a आ गया है. So we need one more equation, one more relation between a and f जिससे हम फिर सॉल्व कर पाएंगे. So what we can do, we know that highest point reach करती कोई भी बॉडी तब उसकी फाइनल वेलोसिटी हो जाती है 0. ऑलराइट, और क्वेश्चन में इनिशियल वेलोसिटी भी दी हुई है 40. And what else do we have? We have the time as 3 seconds and acceleration हम पहले निकाल चुके हैं, that is 15 plus f upon 1.5. ऑलराइट, इसमें अपन क्या यूज कर सकते हैं? v इक्वल्स टू यू प्लस ए टी लगा सकते हैं इसमें.
हम्म.
0 इक्वल्स टू यू एंड एक्सेलरेशन नीचे है, मोशन का डायरेक्शन ऊपर है, तो माइनस आ जाएगा 15 प्लस एफ अपॉन 1.5 इंटू 3. सही है. यहाँ से आ जाएगा 40 इक्वल्स टू, ये हो जाएगा 0.5, 15 प्लस एफ अपॉन 0.5, तो 15 प्लस एफ इक्वल्स टू 20, 0.5 इधर मल्टीप्लाई होगा, so F comes out as 20 minus 15, that is 5 newtons. That is the option D. आया सबको समझ में? Anyone having any doubts?
नो सर।
No, sir.
Alright, आगे बढ़े. Three blocks of masses, this and this, are connected by a string and resting on a frictionless incline of 60 degrees. Alright, now a force of 120 newtons is applied upward along the incline to the last block. If the strings are ideal, the ratio T1, this is T1 by T2, will be. Yes, Arnav, right answer. Do you want some hints, guys? See, I tell you a very easy first step, that is, पहले तो आप एक्सेलरेशन निकाल लीजिए टोटल, दैट इज पहले पूरा सिस्टम ही कंसिडर कर लीजिए, उसके बाद में T1 T2 पे बाद में आना. At least we'll find the value of A, so it will get a bit easier. Yes or no? Alright, shall we proceed with the solution?
So just a minute.
Alright, guys, let's proceed with the solution now. See, first, if we take the complete system into consideration, we have F equals to 120 newtons, so that gives us um just a second. Yes, Jen, right answer. Guys, I think we don't even need to find out acceleration in this question. We can directly take both of our systems individually as well, and then we'll find the relations, and that will help us in finding the answer. All right. So if we take the first body, this middle one, this has a force over here T2 and a force here T1. That gives us T2 minus T1 equals to 4A. And if we take the last one, it gives us T1 equals to 2A. All right, so if we put 2A over here, that gives us T2 equals to 6A. And taking the ratios, we get T1 by T2 equals to 1 upon 3. That gives us C as the right answer. All right. All right, next question. A block of mass 20 kgs is balanced by three strings A, B, and C as shown in the figure. Ratio of tensions in string A and B is. No, Jen, wrong answer. It is easy, guys. You just have to use the sine rule.
The triangle.
No, the sine rule which states that if there are three forces balancing each other, then the rule states that each forces divided by sine of the opposite angle are equal in value. Do you know this rule?
So I haven't done this before.
I don't have ISO.
Shall we proceed with the solution?
Yeah, sir.
All right. See, according to the sine rule, yes, Jen, right answer. If we take this point into consideration, this junction point, then we have TB over here, TC over here, and a TA over here. Alright, the angles given are 83 degrees. This is 37. This is 90. So, how much does this angle become? This will come out as 150. Alright, so according to this rule, we have TA upon sine 150 equals to TB upon sine 90 plus 37 equals to TC upon sine 83. Alright, now we want to find the ratio of TA and TB. So we'll only take this much equation, that will give us TA upon TB equals to sine 150 upon sine 90 plus 37. Now this will get simplified to sine 90 plus 60, that is cos 60 upon cos 37. Cos 60 is 1 by 2, cos 37 is 4 by 5. So that gives us answer as 5 by 8. इसमें ये मास का कोई रोल नहीं था. ऑलराइट, आ गया सबको समझ में? एवरीवन? किसी को डाउट
Yeah.
है?
No, sir.
Alright. See, in this previous question, I just remembered one more thing. हमने mg consider नहीं किए थे इनके. So every body will be having its own mg. Suppose this is M1G, दिस इज M2G। तो इन सब के ये परपेंडिकुलर कंपोनेंट्स भी एक्ट करेंगे इन सब में। ऑलराइट, तो दिस इज फर्स्ट वन इज 4, तो इसका ये थीटा हो जाएगा, दिस विल बी mg cos थीटा एंड दिस पैरेलल विल बी mg sin थीटा। तो ये mg sin थीटा दोनों के भी आएंगे कंसिडरेशन में। तो कितना हो जाएगा, 4 into 10 into sin 60, दैट इज, तो आप ये भी अगर कंसिडर कर लेंगे दोनों में, इक्वेशंस में आप ऐड कर लेंगे तो वो अम, आ जाएगा साथ में। T1/T2 आप तब भी करेंगे तो भी 1/3 आ जाएगा। एक्चुअली एक रूल होता है कि जब भी ऐसी चेन बनती है बॉडीज की, कितनी भी बॉडीज हो सकती हैं, और अगर टेंशन के रेशियोज की अगर बात होती है, तो यू कैन जस्ट डायरेक्टली टेक द रेशियो ऑफ द मासेस, कि अगर इसका और इसका रेशियो चाहिए तो ये वाला मास अपॉन ये वाला मास, मतलब वो टेंशन के पीछे जितना भी मास लगा हुआ है उनका आप रेशियो ले लेंगे तो भी डायरेक्टली आंसर आ जाता है। ऑलराइट, तो उसके अकॉर्डिंग यहाँ पे T1 के पीछे 2 है एंड T2 के पीछे है 2+4, तो यहाँ से भी आ जाता है आपके पास 2/6, दैट इज 1/3। ऑलराइट, नेक्स्ट क्वेश्चन। A string of length L and mass M are lying on a horizontal table। ऐसी सपोज एक स्ट्रिंग है, इसका मास भी है, लेंथ L and mass, complete mass M। Now a force F is applied at one of its end, R नहीं होगा यहाँ पे, इस होगा one of its ends, suppose यहाँ पे F अप्लाई किया, then tension in the string at a distance x from the ends at which force is applied is। suppose इस एंड से यहाँ पे कहीं पर x है, तो इस पॉइंट पर टेंशन क्या रहेगा, क्योंकि मास है स्ट्रिंग में तो हर पॉइंट पे टेंशन डिफरेंट होगा। No, enough wrong answer. No, Ashwat, wrong answer. I'm sorry. Guys, do you want some hint? See, guys, try to find out the acceleration of the complete mass first, and then try to break down this string into two parts. Alright, just to visualize the tension more clearly, we can break down this string into two parts and consider one mass for our calculations. This will be having tension T like this and force F like this. So in that case, you can take two different situations. So you will get two different equations, and then you'll able to solve for the variables. Alright guys, let's proceed with the solution. If we take the complete mass into consideration, we will have F equals to m into A. Suppose it's having an acceleration A. So first we have F equals to ma, and then if we take a small partition at a distance of x and mass small m, then we can have F minus T equals to m into A. Alright, acceleration will be same, but we have taken the small m on our own. We have to take this in terms of given distance x. Right, so how can we do that? We can use the mass density. Mass density is total mass upon total length, and multiply it by the given length, we get mass of the smaller body. So this will become m by L x into A. This is F minus T. Now we have m and A here, and we know that ma equals to F. So we can substitute this F x by L, and from here we get T equals to, it goes over there, it goes over here, F minus Fx by L, F common, and LCM L minus x by L. That is option C. आ गया समझ में?
Yes, sir.
Alright, let's take one last question for today. Three blocks M1, M2, and M3 of the given masses are placed in contact, and then two forces are being applied in two different directions. Then the reaction between the blocks M2 and M3 is, that means there is a reaction at this contact. You have to find its value. इसमें ट्राई करना, पहले टोटल एक्सेलरेशन निकाल लो, उसके बाद में फिर इंडिविजुअल बॉडीज के ऊपर देखना। Anyone with the answer? Or shall we proceed with the solution?
1 minute.
All right. Yes, Jane, right answer. All right, guys, let's proceed with the solution. See, considering the complete system, we have this total mass and it is having 140 newtons over here, 20 newtons over here, and total mass of the system is 12 kgs, right? And suppose this is completely moving with an acceleration a. So we get 140 minus 20 equals to 12 into a, that is 120 equals to 12a, so a equals to 10. All right, now let's take any one mass for consideration. Let's take the last one because of our convenience. So this mass m3 with 1 kg is having a force F2 over here and a normal reaction by M2. Let's name this N23. Alright, so we can write the equation N23 minus 20 equals to 1 into A. A we have calculated as 10. So N23 comes out as 10 plus 20 equals to 30. That gives us the answer. That's what we wanted to find out, the normal reaction between masses 2 and 3. Is that right? आगे सबको समझ में?
हाँ सर.
Alright guys, that's all for today. Thank you for joining.
Thank you sir. Bye.
Good night.
Good night.